In this video, we're going to be discussing the topic of base n numbers and solving this problem related to finding mystery bases and solving. So let's start with what base n numbers mean. This involves a specific type of kind of a number theory section of math, where there are several different number bases that can be used to represent digits. So we as humans use the base 10 number system on a day-to-day basis, the one you're all familiar with from 0 to 9, all the digits in between. But there are actually several other number systems that may also come in handy for topics and tasks such as computing. For example, the base 2 number system, and it's so-called base 2 because there are only two digits, 1 and 0, available for use in that number system. Base 2 is very commonly used in computer and technical applications because it's very easy and fast to compute. So in base 2, we've only got two digits, 1 and 0, kind of like an on and off switch. And there are different ways to convert between base 2 and base 10 and in and out of each base. So basically a number base, is a number system that contains a set amount of starting digits. For example, base 2 contains two digits, 0 and 1. Base 3 contains three digits, 0, 1, 2. Notice that base 3 does not include 3. It only includes up to that number, not including it. And base 7 would include 0, 1, 2, 3, 4, 5, and 6. And just with base 10, this is a very important fact. A number cannot start with the digit 0. Just like you couldn't have the number 0, 1, 5, 6. In base 10, you couldn't have the number 0, 2, 3, 7 in base 8, for example. So now that we have knowledge of what base n numbers are, where n is like your base 2 or your base 5 or your base 7, let's now dive into this here problem. That states, there are exactly 100 three-digit base b numbers. What is b? Where b is some mystery base, like for example, base 6 or base 8. And we're trying to find this mystery base b. So, we need to know, they tell us exactly 103-digit base b numbers. That means we need to divide the number of choices for each digit up into 3. So there are 3 digits, put some lines here, times this, because we're trying to figure out which base this is. So we want to know how many, well not how many, but just to get an idea what we need to multiply in these blank spaces for digits 1, 2, and 3. I'm going to write digit 1, digit 2, and digit 3. So, we know that the first digit cannot be 0 because that's just not possible. You can't have a number starting with 0. So we put b minus 1 here, because removing 0 removes one choice from the total amount of values available. For digit 2, it can be anything within the realm of the base b number, so all we put is b. Same for the third digit. The second and third digits can be relatively anything, whereas the first one can only be something excluding 0. So now we have 3 digits here and a way to represent them in terms of b. b minus 1 times b times b. So from here, what we need to find out is what 3 numbers fitting this form multiply to 100. So basically, what would b equal in this situation so that this product is equal to 100, since we know that there are a total of 103-digit base b numbers. So, to find the b available here, all we have to do is do a slight bit of trial and error. It's actually pretty easy to find out, and you should come to the conclusion pretty quickly. If you start at, for example, b equals 3, you'll find that you have 2 times 3 times 3. This is too low because you've got 9 times 18. You can then systematically improve your answer from there, going up. You can try 4, that'll still be too small. Then once you get to 5, b minus 1 would be 4 times 5 times 5. So then you can test this, multiply it, 5 times 5, 25, times 4, 100. Bingo, you have your value of b. So in this case, b equals 5, and that is the base b. So that's 5. And that's how you solve a base n numbers problem. This is one of the most basic ones, about 3-digit base B numbers.